For this ellipse equation, x squared plus 3y squared equals 2, the derivative is 2x plus 6y dy dx equal to, what's the derivative of 2? Can't fool you. So we'll have 6y dy dx equal to negative 2x. So we'll have dy dx equal to negative x over 3y. Anybody disagree with that? Is that all right? Find the equation of the, oh, we don't have the equation yet. All I have is the equation for finding the slope. So I take this point, then the slope is just going to be negative x, which is 1 over 3 times 1 over the square root of 3. And so the slope is just going to be negative 1 over the square root of 3, because one of these square root of 3's will cancel. So x minus 1 times negative 1 over the square root of 3 is equal to y minus 1 over the square root of 3. That is the equation for the tangent line. For the normal, that perpendicular slope will just be what? This slope is negative 1 over square root of 3. What will the perpendicular one be? Just the root 3, right? So if that's your normal, or that's your slope, then you just go x minus 1 times the slope equal y minus 1 over the square root of 3. So you can see how this one only gives you 2 marks, 1 for finding the slope and 1 for finding the equation. This is my first answer and second answer. Okay. And it says, given that the tangent crosses the x-axis at P, so take the tangent, the tan line, and it crosses the x-axis at P, so that's going to be x comma 0. Y is equal to 0. Negative x minus 1 over the square root of 3 equals 0 minus 1 over square root of 3. So the negatives will cancel, and the root of 3's will cancel, and I'll get x is equal to 1 plus 1, which is 2. So this point is 2 comma 0. And then it says the normal crosses the y-axis at P. So this is my, or Q. P is 2, 0, and then we're going to find the normal line, and that's going to be 0y because it's crossing the y-axis. So we're going to take the normal line, and we're going to let x equal to 0. So we'll have 0 minus 1 times the square root of 3 equals y minus 1 over the square root of 3. So this is going to be negative square root of 3 plus 1 over the square root of 3 is equal to y. And so if I, yeah, so I'm going to multiply top and bottom here by square root of 3. So I'm going to get negative 3 plus 1 is negative 2 over square root of 3 is equal to y. So this point is going to be 0, 2. Is it negative 2 though? Yeah, negative 2 over the square root of 3. That's cute. Now, what are they asking us to do? What are they asking us to do in part 3b? Find the what? Find the equation of that. So we need to find the slope. So I'm going to do that next. The slope is the change in y, which is 0 minus 2 over the square root of 3 over 2 minus 0, which is 2, which is going to be 1 over the square root of 3. Okay, and then do we have a point? Absolutely, we've got a bunch of them. Here's an easy one, 2, 0. So we're going to have x minus 2 times 1 over the square root of 3 is equal to y minus 0. So there's the equation for PQ. Then it says, hence, show that PQ touches the ellipse. So how are we going to show that PQ touches the ellipse? Well, here's the ellipse equation up here. Here is PQ. So what I'm going to do is I'm going to use this and prove to you that it's touching the ellipse. So the way I would do it is I would just I would take that x squared plus 3y squared. Here goes. X squared plus 3y squared equals 2, right? And I'm going to put this y right here. X minus 2 times 1 over the square root of 3. Are you okay with that? I got a positive slope for that one. Won't matter because you're going to square it, but was it negative? Okay. Now let's square this, and you're going to get x squared plus 3 times x minus 2 squared over square root of 3 squared is 3. What happens to the 3's? They cancel. So you're going to get x squared plus x squared minus 4x plus 4 equal 2. And 2x squared minus 4x, subtract 2, plus 2 equals 0, or x squared minus 2x plus 1 equals 0. Does that factor? How does it factor to get negative 2? Scaring me. Okay. Yeah. So what does this mean if you get x minus 1 squared equals 0? What does that tell us? That the line and the ellipse meet. Remember when we did parabolas? And there were 3 possibilities: 2, none, and 1. What was the possibility? What was the only way that you could have one intersection? Is if both of these are the same. So you would say, therefore, since x equal 1 is a double root for intersection, then PQ intersects in one place. Point on ellipse. I love how this one leads to the next one. Now we go to D. State the coordinates of the point where PQ touches the ellipse. Well, what's the x value where it's going to touch? 1. So then you put that into the original equation, and you're going to get 1 squared plus 3y squared equals 2. And you're going to get 3y squared equals 1. Y squared equals 1/3. Y is equal to plus or minus 1/3. Now that's not helpful. We only want one of those. Or square root of 3, yeah. square root of, but even still, that's two answers. I only want one answer. So maybe I need to use the line PQ. You think? So let's do that. 1 minus 2 is equal to y. So this is going to be negative 1 over the square root of 3 is equal to y. So that we're going to want to use the negative 1. So I think it's 1. I think it's going to be 1 negative 1 over square root of 3. That's what I think it's going to be. A, B, C, and where is, oh, C. Did they get, do I have that point? D, 1 negative 1 over square root of 3. Got it. So if I remember, you go x squared over 2 plus 3y squared over 2 equals 1. And then this will just be y squared over 2/3, right? So a is the square root of 2, and b is the square root of 2/3. And then we remembered that b squared equals a squared 1 minus e squared to find e squared. So 2/3 equals 2 times 1 minus e squared. I don't think so. They should be, but I don't think they are. So then you're going to get 1 is equal to 3 minus 3e squared. And you'll get negative 2 equals negative 3e squared. I get 2/3 equal to e squared. E is the square root of 2/3. Did they say plus or minus? It just is that. Square root of 2 over 3. I think so. Because what you're going to do is you're going to add and subtract that. So, well, they have the focal point is plus AE comma 0 because it's the x-axis. What's that? Are you thinking hyperbola maybe? Yep, I like it. So A was square root of 2 times square root of 2 over 3. And that's just going to be 2 over the square root of 3. And then the other one is going to be negative 2 over the square root of 3. And they're saying x-axis, so that's why it's the 0 is in both places. Then directrix, right? Or find the equation of the directrices of that. So this was part E. Part F. F, you're just going to use x is equal to plus or minus a over e. So x is going to be plus or minus, remind me what a was again? Square root of 2 over square root of 2 over square root of 3. So I think that's just going to be plus or minus the square root of 3, isn't it? Yeah, formulas. Got a couple formulas there. This is the formula for the foci. This is the formula for the directrix.